Hello everyone, welcome to my channel. In this video we are going to see about the synchronous motor and the constructions of the synchronous motor and their types and applications. So normally a synchronous motor is a AC motor in which uh, at steady state rotation of shaft is in sync, which means in sync with the frequency of the applied current. So uh, from this we can easily came to know that the synchronous motor will not depend on the varying loads. It's directly depend on the uh, controlling ability of your frequency by a applied current. So if an electromagnet is present in the rotating magnetic field, the electromagnet is magnetically locked with the rotating magnetic field and rotates at the same speed as a rotating speed of the field. It is a fixed speed motor because it has only one speed, which is your synchronous speed. So the speed is synchronized by applying a frequency. So the formula is that synchronous speed is equal to 120 frequency divided by the number of poles. So in here, with the frequency controlling, we are able to control the speed of your motor. Next is your construction. So in here, the commonly in a synchronous motor we have two main parts as a stator and rotor. Stator is your stationary part and rotor is your rotating part. So the stator is further having a some of the parts as a stator frames and stator cores and stator windings. So the stator frame in the sense the outer covering, which means the outer body of your machine made up of a cast iron and it protects the inner part of your machines. So it is your outer yard kind of thing. It protects from the external environment. Then stator core. Stator core is made up of a silicon steel materials. It is made up of some of the sections, which means small sections which which are being grouped, and then uh, it functions to provide an easy path for a magnetic lines of force and accommodate the stator windings. So further the stator winding is having a some of the slots and cut in the inner peripheral of the stator core. So as you know, the AC supply is a single phase or a three phase, which accordingly we will use, and enabled in a copper, which is used as a winding material. The winding is a star connected. So the each winding of each phase is distributed in a several slots, and current also flows in a distributed winding, and it provides a essential sinusoidal space for your uh, EMF producing. Next is your rotor. So rotor is having a two types of rotor constructions. One is your silent pole rotor and second one is your non-silent or a cylindrical rotor. So your silent pole rotor in the sense it consists of a poles projecting out from the surface of the rotor cores. So since the rotor is subjected to changing magnetic field, it is made up of a steel laminations to reduce the eddy current losses, and the poles of identical dimensions are assembled by a stacking laminations to provide a length. And this type of silent pole rotors are mostly used in your medium and low speed devices because of their large number of poles. Nearly about 6 poles will be presenting in your silent pole rotor. Then coming up to the non-silent pole rotor or a cylindrical pole rotors, in this rotor there is no projected poles, which means the poles are formed by your current flowing through the rotor exciting windings. So normally the cylindrical rotors are usually made up of a solid forings of high graded nickel chrome molybdenum steels, and these rotors are mainly used in your high speed machines. Then this cylindrical rotor will having a seven parts, which is your cylindrical rotor core, then rotor winding, which is your exciting winding, and pole core and pole shoes, and field windings, and dapper winding, and rings. So these all seven parts will be included in your cylindrical rotors. You can just have a look into this. This is if we are using the cylindrical type of rotors means this all parts will be included. If we are going with the silent pole rotor means this all will be omitted. Next is your brushes. Brushes are made up of carbon and they slip over the slip rings. So a DC current is given to the brushes and current flows from a brushes to a slip rings and then to your exciting windings, because the DC supply is used for as a external exciting for your rotors. That's why we are using these brushes. Then bearings which carries a shaft and the outer stationary body to reduce the frictions. They are made up of a high carbon steels. Then shaft. The shaft is made up of a mild steel and mechanical power is given to your machines through the shaft. This is the example of your synchronous motor. So as I said, stator, which means first the frames, which is your outer covering, and then the stator which is having a stator's windings, and rotor which is your silent pole rotor, uh, which is having a field windings, and then the DC supply is given to the field winding and the three phase supply is given to the stator pole windings. So in here, uh, the DC supply is given to your field winding because of their not ability of your starting thing. So that's why we are going with the external self starting kind of thing. So we are giving a external supply to your field windings. This is the path of your magnetic path of your motor. In here, magnetic flux lines, field conductors, iron rotors, stator conductors, slip rings, iron stators, and end conductors are been presenting. Next, coming up to the principal operation. So the operation of the synchronous motor is that the rotor follows the rotating magnetic field of the stator and rotates at a speed approaching it. So the rotor winding is excited by a DC source and the stator winding is excited by the AC source. From here we can clearly know that the DC supply is first used for your rotor windings and AC supply for your stator windings. So in here, for working purpose I am using the silent pole rotor example. So uh, next is that we are going a three phase supply for your AC supply for your stator, and three phase rotating magnetic field is produced in your stator winding, and the rotor winding produces a constant magnetic field. So at some rotation the poles of two magnetic field will attract each other, while at some instant they will repel each other because of their different polarities. Then further, the rotor will not start to rotate due to its inertia, which means it is in resting position. So we need a external source, and that external source will be a DC source, will be provided for a initial rotation. Once the rotor gets rotated, automatically uh, the external source will get cut off, and the magnetic field of the rotor is not produced by the magnetic field of the by the rotor but through the induction. Next, coming up to the types of synchronous motor. In here we have mainly two types: non-excited synchronous motor and direct current excited synchronous motor. This non-excited synchronous motor is further classified into a hysteresis synchronous motor, reluctance synchronous motor, and permanent magnet synchronous motor. Next is your advantage. The main advantages of your synchronous motor is that the electromagnetic power varies linearly with the voltage in a synchronous motor. Then the synchronous motor usually operates with a high efficiency for a low speed, comparing with the induction motors. Then they can operate under any power factor, lagging as well as leading. Hence the synchronous motor can be used in your power factor improvement also. Then the speed remains constant irrespective of the loads. As you know, the main thing is that uh, for us for a constant speed with a varying load, we are going with the synchronous motors. Then the synchronous motor are built with a wider air gaps than induction motors, which makes them mechanically more stable comparing with the induction motors. Then coming up to the disadvantages, the main disadvantages is that It requires a DC excitations which is supplied for external sources. Then second thing is that the motor is not a self-starting. So as you know that for a initial stages we need a external source for your field windings. Then the cost per kilowatt output is commonly higher than the induction motors. Then unless the incoming supply frequency is adjusted, there is no possibility of adjustment of your speed. As you know, once we need to control the frequency, then only we can able to control the speed of your synchronous motor. Then they are not started on a load because it's having a starting torque as a zero or a very low, so we cannot able to start the synchronous motor with the load. Then slip rings and brushes are required, which results in a high maintenance cost. Then the synchronous motor cannot be useful for applications with a frequent starting. For immediate running we cannot use this synchronous motor kind of devices. Or if we going with this synchronous motor also, we need to keep more precautious, like variable frequency drives and rectifier units for continuous supply, incoming supplies. We need to keep or we need to add additional quantities in order to go with this synchronous motor. Next, the applications. The synchronous motor is capable of operating under a leading and lagging power factors. So it is mainly used in a power factor improvement, and also a synchronous motor under a no load with a leading power factor. If it is connected with the system, means automatically uh, it will compensate the static capacitors, and also it is used in your high power low speed requiring requirement. So it is used in your rolling mills, chippers, mixers, pumps and compressors. So these are all the basic things of your synchronous motor. In coming up slide we will have a deep discussion on the types of synchronous motors. Have a nice day. Thanks for watching. Nandri, vanakkam.